So, how do scientists actually read our DNA? Well, it all kicks off with a tiny, microscopic race.
I mean, think about it. How do you possibly sort molecules you can't even see? It's a huge challenge. Turns out the answer is to create a tiny race course. The winner? It's all based on size.
This technique is called gel electrophoresis, and trust me, it's an absolute game changer in modern biology.
You'll find it everywhere. We're talking forensics, genetic diagnosis, you name it. This is the tool.
Okay, so how does it actually work? Well, the gel itself acts like a superfine sieve, a tiny obstacle course.
First, you apply an electric current. See, DNA is naturally negatively charged, which is key here. That charge pulls it towards the positive end. And here's the clever bit. Smaller pieces just zip through way faster.
Now that race course, the gel, comes in two main types. You gotta pick the right one for the job. Agarose is your go-to for big chunks of DNA. For the really tiny stuff, you want polyacrylamide.
And making the gel? It's kind of like making a high-tech Jell-O, but for, science.
But it's a real balancing act. The gel's concentration has to be just right for it to work.
The buffer solution is also super important. Think of it as the juice that conducts the electricity.
All right, so the gel's ready. Now we get our samples to the starting line for the big race.
We mix in a colored dye. This helps the sample sink into place and lets us see how it's moving. Then we connect the power. And a great little trick to remember, DNA always runs to red.
Now this is pretty cool. The voltage is a trade-off. You can go fast and get messy bands, or slow and precise.
Okay, race over. But wait, DNA is invisible. So how do we actually see the results?
That's where staining comes in. You can do it before, for speed, or after for the absolute best results.
What you want are sharp, clean bands. If you get a blurry smear, yeah, that's not good news. And for some samples, there's a pro tip. A good result means the top band is twice as bright as the bottom one.
As powerful as this is, we've got to talk about safety, because there are some very real hazards. You're dealing with electricity, some pretty serious chemicals, and even UV radiation to see the bands. So yeah, following the safety rules and wearing all your gear, that's 100% non-negotiable. Seriously. But when it's done right, it takes a totally invisible jumble and turns it into a clear, readable result.
And really, that's the whole point, right? Making the invisible visible. That's the magic of science.